Hi, this video I'm going to talk about the normalization concept in DBMS. First, I will say about what is meant by normalization. So, normalization means it is a technique of organizing data into more than one table in a database. It is actually a systematic approach of decomposing tables to eliminate data redundancy and undesirable characteristics like insertion, updation, and deletion anomalies. The purpose of doing normalization is the main purpose is to eliminate the data redundancy, and other thing is to avoid the insertion, updation, and deletion anomalies. How we can do the normalization? It is a multi-step process actually that puts the data into tabular form, removing duplicated data from the relational tables. As I told, we will do the normalization because of two main reasons. One is to eliminate the redundancy data, that is data redundancy. To eliminate that, we will use the normalization. And other one is to ensure data dependency. For that purpose also, we will do the normalization. And what is the problem without a normalization? Without normalization, it becomes difficult to handle and update database without facing any data losses. And the insertion, updation, and deletion anomalies are very frequent if the database is not normalized. These are the problems can occur if your data is without normalization. First one is it becomes difficult to handle and update the database without facing the data loss. And insertion, updation, and deletion anomalies are very frequent if the database is not normalized. And what are the anomalies? We have three different types of anomalies. We have one is insertion anomaly, second one is a deletion anomaly, and third one is a updation anomaly. So what is meant by insertion anomaly means it refers to when one cannot insert a new tuple into a relationship due to the lack of data. That is actually insertion anomaly. Second one is a deletion anomaly. So the delete anomaly refers to the situation where the deletion of data results in the unindented loss of some other important data. That is actually a deletion anomaly. And third one is a updation anomaly. The update anomaly is when an update of a single data value requires multiple rows of a data to be updated. Whenever I want to update a single data, I need to update the multiple rows of data. That is actually updation anomaly. Here I gave one example. So here we have four attributes in this relation: student ID, student name, student address, and subject, and four rows are there. So updation anomaly, to update the address of the student to occurs twice or more than twice in a table, we have to update the address column in all the rows, else the data will become inconsistent. That is actually updation anomaly. Second one, insertion anomaly. Suppose we have a new student for an admission, and we have student ID, student name, and student address of a particular student, but the student has not opted for any subject. Then we have to insert null for the subject, which leads to insertion anomalies. So whenever the student is coming for an admission, student ID, student name, and student address is available, but the subject is not opted means that column becomes null. So which leads to insertion anomaly. And what is deletion anomaly means? If a student ID 401 has only one subject. Okay, here actually student ID 401 has only one subject, that is a biology, and temporarily drop it. When we delete that row, the entire student record will be deleted along with it. That is a deletion anomaly. And what is meant by normal forms? As I told, the normalization comes from the concept of normal form, which describes how to organize the data in the database. It were developed around the concept of table based on the relational database. There are different types of normal forms. 1NF, that is first normal form, 2NF, second normal form, 3NF, third normal form, BCNF, Boy's Code normal form, 4NF, fourth normal form, and 5NF, fifth normal form. These are the different types of normal forms. We will see one by one. This is an example for the unnormalized form. If a table contains one or more repeating groups, it is called unnormalized form. For example, here I have a course and content. Here in the first row, I have programming and web. This is not a repeating group, but here in the content, C, Java, and Python. These are repeating groups. Similarly, HTML, ASP, and PHP. These are repeating groups. This is actually a unnormalized form, and we are going to normalize it. So, as I told, there are different normal forms I told. We will see one by one. First, I will tell about the first normal form, that is 1NF. So, when we say that a relation is first normal form is, there are two constraints. If and only if all the attributes of a relation are atomic, that is, it should be single valued in nature and must not contain any multi-valued or composite attributes. These are the two conditions for the first normal form. All the attributes of the relations are atomic, that is single value in nature, and must not contain any multi-valued or composite attributes. This is actually this particular table. It is not in 1NF, that is first normal form, because here we have three values. It is not a single value. Content is not single valued, it is multi-valued. So what we are going to do is we are going to normalize it. So the relation consists of multiple values, multi-values actually, hence it is in first normal, it is not in first normal form. The multi-values are eliminated and are written separately for each. So multi-values are written as atomic, that is here programming. So this is actually, we have a programming. This programming actually, here we are dividing this multi-valued, these are multi-valued C, Java, Python. So we got divided into single value, programming C, programming Java, programming Python. Similarly, this also multi-valued, HTML, ASP, and PHP. These are multi-valued, and again we are normalizing it. So web, HTML, web, ASP, and web, PHP. Okay, so web, HTML, and web ASP, and web PHP. So now all are single valued. So now we have eliminated the table because it is not normalized, it is an unnormalized format. So we are converting into first normal form. So this 1NF allows a data redundancy, and there will be many columns with the same data in multiple rows, but each row as a whole will be unique. Okay, the problem in 1NF is it allows data redundancy, and there will be many columns with the same data in multiple rows. Here the programming actually same. This is redundant. Similarly, web is also redundant. Okay, so where we use this 1NF application is we can use it in most small to medium application. This is where we applied the first normal form. Next one is second normal form. So second normal form, again here also we have two conditions. The relation is said to be in second normal form if and only if it is already in first normal form. First normal form means it should be a single value. There exists no partial dependency. What is meant by partial dependency means? It means that it means that a non-prime attribute is functionally dependent on part of a prime attribute. That is a partial dependency. And what is fully functional dependency means all the non-key attributes are fully functionally depends on key attribute. Here actually non-prime attributes is functionally dependent on part of a prime attribute, but here fully depends on the key attribute. That is actually functional dependency. So here an example for full dependency and partial dependency. Assume that we have 6 attributes, attribute A and attribute B, attribute C and attribute D, and attribute E and attribute F. Assume that A and B are primary key. Okay, so attributes A and B are primary key, and C, D, E, F are non-key attributes. And here C, D, E, F. So these are the non-prime attributes C, D, E, F. All are depend on primary key attribute, that is A and B means, then it is a full dependency. So as I mentioned here, so here these are the non-prime attributes, non-key attributes, that is C, D, E, F. These all non-key attributes are dependent on the primary key attribute, that is A and B. So this is actually called as full dependency. Partial dependency means only C and D are dependent on B. Okay, so B means it is a primary key and C, D are non-primary attribute. So still some more attributes are there. Some more non-primary attributes are there, non-key attributes, that is E and F, that is not dependent on attribute B. So in this case, it is a partial dependency. So if we have partial dependency, we have to eliminate to get a second normal form. So create a new relation for each primary key attribute that is a determinant in partial dependency. Move non-key attributes that are dependent on primary key attributes from old relation into a new relation. Now I will show one example. Here in this example, employee ID is a primary key. This is actually the primary key, employee ID. All the non-key attributes are depends on the employee ID. That is employee name, month, sales, B name. These are dependents on the employee ID. But B name, here actually this B name depends on BID. Okay, this B name is actually depends on BID, which is not in second normal form. So second normal form means all the non-key attributes should be dependent on primary key attribute. So this table is in 1NF, but it is not in 2NF. So after removing the position into another relation, store the lesser amount of data in two relations without the loss of data. Now I am going to convert this table into second normal form. This is actually the original table. Now I am going to apply the second normalization. And what I did is employee ID, employee name, month, sales, and B name. Okay, so here BID is a primary key. So this one I have divided into separate table, and B name and BID. So here B name is a non-prime attribute, and non-key attribute, this is now depends on BID. Okay, now here we have fully depend, we will get the full dependency. And here also BID, sales, month, E name are dependent on the employee ID. Now we have eliminated the previous table, and we will get the second normal form. In third normal form, a relation is said to be third normal form if and only if it is already in second normal form. That is, it should have a full dependency, and there exists no transitive dependency. What is transitive dependency here is, assume that in this table I have 4 attributes A, B, C, and D. Now C is depends on A. Okay, C is depends on A, and D is depends on C. D is depends on C. Now we have transitive dependency means D is depends on A. D is depends on A. This is actually called as transitive dependency. So we have 4 attributes A, B, C, D. So C is depends on A and D is depends on C means. So what is meant by transitive dependency means D is depends on A. That is A tends to D. This is actually transitive dependency. As far as third normal form is concerned, it should be in second normal form, and there should not be any transitive dependency. And look at the table here. This is actually transitive dependency. A tends to B and B tends to C. Okay, if you have a relation like this, B is depends on A and C is depends on B. Then we can write that A tends to C. That is, C is depends on A. Okay, here I gave an example. So mark is depends on roll number. Marks is depends on roll number, and the grade is depends on the marks. So now we can write the transitive dependency, that is grade is depends on the roll number. That is, roll number tends to grade. This is actually called as transitive dependency. So now we are going to eliminate this transitive dependency, because whenever we need to follow the third normal form, it should not have the transitive dependency. How to eliminate the transitive dependency is, for each non-key attribute that is determinant in a relation, create a new relation that attribute becomes a primary key in a new relation. So move all of the attributes that are full or functionally dependent on attribute from old relation into new relation. Leave the attribute in old relation to serve as a foreign key. I will show the example. Here this is a table, student ID, student name, city and pin code. And we have a transitive dependency. How we can have the transitive dependency is student name depends on student ID, city depends on student name, pin code depends on city, means then student ID tends to pin code. We can have a transitive dependency like that. Now we have divided the table. So student ID, student name and pin code. Okay, student ID, student name and city, pin code. So that we have divided into one table, and pin code and city we have divided into another table. Okay, this is actually called as third normal form. Fourth normal form, boys code normal form, and fifth normal form we will see in the next video. Thank you.